All right, I think we'll get started. So welcome everyone to the lecture this evening. I'm Andrew Witt, Associate Professor in the Practice of Architecture and Co-Director of the Masters in Design Engineering program under which this lecture is being presented. So tonight we'll be favored to hear a lecture by Dr. Theodore Spyropoulos entitled Quantum. But first, I wanted to share a couple of important announcements. So the Harvard Graduate School of Design is located on the traditional and ancestral land of the Massachusetts, the original inhabitants of what is now known as Boston and Cambridge. We pay respect to the people of the Massachusetts tribe, past and present, and honor the land itself, which remains sacred to the Massachusetts people. The school also recognizes the work of the Harvard University Native American program in cultivating the relationships that led to the creation of this acknowledgement. Also, I wanted to share a quick reminder that we have live captioning available tonight to our virtual and in-person audience. Those joining virtually can enable captions by clicking the closed captioning icon on the bottom of the live stream window. For our in-person audience, live captioning is available through the QR code currently on screen. Please visit Matt in the AV booth if you need assistance with this feature. We also have a couple of exciting upcoming lectures. On Thursday, October 17th, the Kenzo Tange visiting critic, Sean Godsell, will transport us to the hot, dry Australian outback. He'll discuss his architectural practice under the dreamy, half-real skies of the bush. On Monday, October 22nd, Yala Makazumi will deliver the Aga Khan program lecture, Landscape, Garden, and a Colonial Legacy. So, detailing her search for a grounded language of landscape architecture in tune with regional ecology and cultural values. So I also wanted to announce that tonight's lecture is supported by the Rachel Dorothy Tanur Memorial Lecture Fund. The fund was established in 2006 and funded by Tanur's family, along with GSD alumnus Ruben Mark. Tanur was an urban planner and lawyer who cared deeply about people, their lives and conditions. And so I feel like it's particularly appropriate and suitable that the Masters in Design Engineering lecture series would be hosted under the banner of this lecture. So on to tonight's event. The Design Research Lab at the Architectural Association is a storied program at a storied institution. For more than 25 years, it's been a global catalyst for expanding the technological imagination of architecture. And in doing so, it's redefined what research as an act of disciplined creativity can be. Yet, over his time at the DRL, and most recently as its director, Theodore Spyropoulos has done, in my opinion, something extraordinary, which is to infuse this already rich research culture with a host of new, vigorous, and highly relevant concerns to meet our generational crises. From planetary dynamics to atomic models of design method, Theo's research is as expansive as it is tangible. Moreover, what struck me in recent reviews of his lab's work was a generous curiosity paired with a very human sense of wonder, possibility, and commitment to the promise of design as a conduit for rigorous imagination. At the same time, in the work of his lab and that of Minimaforms, the design practice he co-founded with Stephen Spyropoulos, there's a preternatural intuition for how the elemental building blocks of our material world are an intimate and vital conversation with architecture, nature, and indeed life itself. In his work, these elemental molecules centrifugally blossom from an exact experimental method into richly complex but always tangibly specific prototypes, designs, and architectures. His books, including Adaptive Ecologies, forthcoming publications such as Quantum and Elemental Phenomena as Technology, place these investigations on a rich theoretical foundation. And a host of exhibitions from the FRAC Centre to the Signum Foundation, M+1 Archigram Archive, MOMA NYC, the Barbican, and elsewhere have showcased this work globally. Theo's alchemical work is refining a mode of design that is unusually intelligent, beautiful, and potent. And I eagerly await what he has to share with us. So with that, Theo.
Okay, thank you so much, Andrew, for that very warm welcome. For me, it's a great privilege to be here with you, to have the opportunity to share some of the work that I've been involved in for the last couple of decades. I also feel quite privileged to be invited under Rachel Dorothy Tanur's memory, as I feel from what I've read of her work and her interests, she was a humanist. And I think at the heart of a lot of the things that I explore, either with myself, with my brother under the banner of Minimaforms or at the Design Research Lab, is in some sense trying to humanize technology and to move beyond, let's say, traditional boundaries of what we actually somehow speak towards when we talk about disciplines. The talk today is titled Quantum. And in a sense, it's a kind of, let's call it a work in progress of a forthcoming publication that is looking at the issues of quantum physics, the subject of relationality, issues to deal with artificial intelligence and different forms of intelligence, and speaking, I think, to some ideas towards the ideas of complexity. So what I'll try to do is share basically some of the subject matter that encompasses the book and an exhibition that we recently had titled The Order of Time, that takes its title from the work of Carlo Rovelli. George Spencer Brown spent a portion of his life writing a book called Laws of Form, and he said, draw a distinction, the universe comes into being. It was his attempt in some way to bridge a kind of artificial gap between mathematics and philosophy. And I think a lot of the things that I'm involved in and a lot of the, I think, work and discourses that resonate with me are in some sense trying to speak to the role of the observer and how that plays a fundamental way of thinking about how we can think of ourselves participating in systems, if they're human with other human, if they're human with machine, or if they're machines with other machines. Exploring, I think, a much deeper kind of understanding of the in-betweenness of things and the relationality of that. Quantum physics in particular, I think, is a very exciting domain to be not only inspired by, but I think to situate within, I think, an ongoing legacy of experimentation, not only in architecture and philosophy, but seeing the relationships is also to question the use of language. Physics doesn't recognize past and future, it's in the now. And that relationality, I think, is something that is very important. For Carlo Rovelli, properties of quantum systems are not intrinsic or absolute, but relational. A system state or properties exist in relationship to other systems or observers. Quantum states do not have definitive properties until they are measured and can vary depending on the observer's perspective. I'm going to speak about the role of the observer, and I'm going to try to link that to a discourse that was emerging in, let's say, the late 50s, 60s, and 70s, which was around the subject of second-order cybernetics, which was looking at the design of systems, but with the observer as part of the system. And Umberto Maturana would say, anything said is said by an observer. And a man named Heinz von Forester would say, anything is said to an observer. The world, as Heinz von Forester, who was in charge of the biological computation lab at IIT, said, the world as you see it is your own invention. It was the idea and the understanding that everything that we see is our own, and in some sense it foregrounded the issues of communication and the importance of that to be something shared. And in my own history, doing a lot of research on behavior-based systems, it was a very important kind of way to think about a certain discourse that wasn't tied to a particular discipline, but really a conversational practice inspired by people like Gordon Pask and others, Gregory Bateson, and such. Within this exhibition, I had the privilege of having Carlo Rovelli come to the studio and to discuss not only his work in relationship to physics, but also the whole idea and the way that we think about a method and practice of exploring ideas that in a certain sense are elusive, intangible. And he spoke about the relational properties, where he said that properties of quantum systems are not absolute. Instead, they're relative to the observer and measured within a context. This means that a quantum state does not have definitive properties until it's measured, and properties can be varying depending on the observer's perspective. He would speak about the observer's dependence, the relationship between observers and systems. If two observers measure a quantum system, they may arrive at different conclusions about its state based on their interactions and the context of their measurements. There is no objective state of a system that applies to all observers. It somehow echoes, I think, in the same way, a philosophy called radical constructivism that was basically taking on board some of the issues that Heinz von Forester was speaking to and opening up that discourse in ways that were challenging the fixed and the finite and operating in a world where everything is dynamic and evolving. The video that's playing in the background is the exhibition that opened at the AA, which was meant as a conversation, in a sense, to bring some of the discourses of not only quantum physics, the work of Yona Friedman, and also another participant in the exhibition, in a sense, John Conway with his Game of Life. Contextuality, I think, is something that is very important. When we speak about the possibilities of relationality, it's always in the now. And I think an architecture of the now is something that is important because it constructs a framework which is situated and in some sense is evolving. And that durational aspect, the idea that the only certainty is uncertainty, plays a big role in the work that I develop and in the ways that we sort of approach architecture and design, art and technology. Rovelli says reality is not things but connections. He speaks to quantum physics in the granular sense. His position is a relational position, which is a different one from someone else that I'll speak about briefly, David Deutsch, who believes in the multiverse and other issues like that. But both of them share a certain kind of challenge, I think, to the Newtonian way of absolute view of space and time. Newton claimed space and time acted as a container for the contents of the universe. And Leibniz spoke to it as a relational one. The view of space and time were nothing more than the sum of total distances and durations between all objects and events in the world. If we remove the contents of the universe, we remove the space and the time. Rovelli speaks of the world and time as something that is plural. Time is a human construct. It's an artificial one. He speaks to the fact that time at the top of the mountain is different than at the bottom of the sea. He speaks about the challenges of the way that we organize ourselves, the way that we deal with clocks and the management of systems. He says we see the world and we describe it, we give it order. We know little of the actual relation between what we see of the world and the world itself. We know we are myopic. We do not see the atomic structure of matter, nor the curvature of space. We see a coherent world that we extrapolate from our interactions with the universe, organized in simplistic terms that our devastatingly stupid brain is capable of handling. A lot of the work that we've been looking at, in some sense, is trying to instrumentalize the act of seeing. This is a photograph of Man Ray, Laboratory of the Future in 1935. It's an important kind of image for me in some of the work that I'll speak to a bit later, but a lot of the research that we're looking at is trying to look at the hidden structures that are basically organizing matter, how waveforms and the whole conversation of physics, if it's a particle, if it's a wave, can be somehow tested not only in slipstream experiments, but in kind of everyday experiments with everyday materials. To talk about the granularity or the fluidity of particle systems like sand, or to look at phenomena as a form of technology like the bouncing droplets that behave both as particle and as wave. These experiments are conducted, those two in particular, by students that are currently in the DRL. And in some sense, that's a very Pulp Fiction interruption. And in some sense, I think it speaks to a certain kind of optimism and curiosity. Andrew spoke about curiosity. And in architecture, we had provocateurs like Hans Hollein, who spoke to the fact that everything could be architecture. In 1968, he basically edited a magazine called Bow. And it was, in some sense, a provocation to the architecture community. In 1997, David Deutsch, a famous physicist and one of very important quantum computing theorists, spoke about the theory of everything. And actually that was supposed to be the title of the book that he published, called The Fabric of Reality. If we go to Hollein for a second, he will say, architects have to stop thinking in terms of building only. Built-in physical architecture, freed from the technological limitations of the past, will more intensely work with spatial qualities as well as the psychological ones. The process of erection will get a new meaning. Spaces, more consciously, have haptic, optic, and acoustic properties. A true architecture of our time will have to redefine itself and expand its means. Many areas outside of traditional building will enter the realm of architecture as architecture, and architects will have to enter new fields. All are architects, everything is architecture. If you look at some of the imagery that Hollein chooses to illustrate, it's also at the early dawn of computers, computer art, first parametric models, the space age, all in some sense sort of questioning how technology would refactor and rethink the role of the architect. In some ways, similar to experiments like the Architecture Machine Group that was down the street at MIT, the practice of architecture lends itself to a form of design research that after 10 years became something called the Media Lab. If we continue into the world of David Deutsch, he speaks about quantum computing. Here is the Bloch sphere as an elemental aspect of what that means and what it means to have a multiplicity of parallel worlds, and the strategy to think about how that, in a certain sense, has a form of entanglement. He says the worldview of Newton's physics was a toolbox that opened the door to Darwin's understanding of the theory of evolution. Now, in the same way, I believe the unsolved problems of the present day, such as the nature of consciousness and creativity, can only be solved within the world of parallel universes. I don't believe that philosophers, whatever philosophers or scientists solve the problems of consciousness, will need to use the equation of quantum mechanics. What they will need is a worldview that quantum mechanics tells us. In some ways, this way of thinking, this subject of thought experiments, the approach of actually using, at sometimes, architecture as a form of resistance, is a way to speculate, I think, in a deeper way, the relationship that architecture may have to a series of other disciplines. Andrew mentioned the Design Research Lab. I've been involved in it now for 22 years, and 18 of them being its director. And one of the fundamental texts, or the two fundamental texts anyway, were Thomas Kuhn's The Structure of Scientific Revolutions and Laboratory Life of Bruno Latour and Stephen Wolger. Kuhn's wrote, the answers you get depend upon the questions you ask. And in some sense, Ravelli and people like David Deutsch speak to the forced relationship of changing perspective from the microscopic to the cosmic, and opening up oneself into a way of sort of thinking and conceptualizing, I think, practice. Within art and architecture, the challenges of sort of trying to argue, to understand space-time, to speak to the challenges of the material world are evident in all kinds of experiments. Richard Serra here trying to catch a piece of lead, or to see the work that he was doing with inscribed systems in asphalt in the urban. People like Robert Smithson in the 70s talking about mirror displacements and entropy, situations which not by chance, were also opportunities where Serra and Smithson also talked about the things that were much more relational, much deeper into the kind of systems that governed. Here, Serra and Smithson are taking a walk on the spiral jetty. These seem, and the work, for example, here of Robert Smithson plays a particular role to the way that the show at the AA was organized. And I'll speak to that a little bit later. One of the pieces that Smithson created, one of his lesser-known pieces, in my opinion, is the Eliminator. The Eliminator overloads the eye whenever the red neon flashes on, and in so doing, diminishes the viewer's memories, dependencies, or traces. Memory vanishes while looking at the Eliminator. The viewer doesn't know what he's looking at because he has no surface space to fixate on. Thus, he becomes aware of the emptiness of his own sight or sees through his sight. Light, mirror, reflection, shadow fabricate the perceptual intake of the eyes. Unreality becomes actual and solid. The Eliminator is a clock that doesn't keep time, but loses it. The intervals between the flashes of neon are void intervals, or what George Kubler calls the rupture between past and future. The Eliminator orders negative time as it avoids historical space. George Kubler, for those who may not know, wrote a book called The Shape of Time, Remarks on the History of Things. He said the universe has a finite velocity which limits not only the spread of its events, but also the speed of our perceptions. The moment of actuality slips too fast by the slow course net of our senses. Smithson says art not only communicates through space, but also through time. And I think there's a history of radical experimentation from Xenakis to the work of Takis, looking at electromagnetic fields, to the work of Xenetos, a Greek architect who was looking at electric urbanism and posing ideas, I think, much earlier than some of the much more known so-called avant-garde or utopian architects of the 70s. The issues of time and space in the work of Kiesler, and this is Kiesler's first version of the Endless House in 1950. You can see as it evolved over 9 years, transformed into a more familiar version from the holistic view to this kind of much more Mobius-like strip, exploring and kind of trying to undermine and use drawing as a tool to investigate what an exhibition could be or what a theater could be. Though a lot of those projects resonate with me, and I feel there's a certain evolution of a form of thinking, I believe that design research is a search, and it's a search to move beyond the representational into the more prototypical. So every opportunity that we have to kind of explore and test those ideas are somehow interrogated within whatever the means that we have, and whatever the scales that we may be working on. Adaptive Ecologies, the basic premise of it was in a book about housing and urbanism that spoke to the fact that there should be no blueprints or master plans. And it was a kind of call for a more generative form of urbanism. Phenomenon as technology, as a form of sustaining life, plays a big role in a lot of the research that not only makes up the two books that I've been working on recently, but speaks to the relationship between quantum fields, particles, space, time. It speaks to the underlying layers that are basically offering themselves up to basically be understood as the constraints in which we can explore space. So a lot of the things that we do in the studio are prototyping ways of just trying to understand understanding, in the sense like Hans Forster would say, in a much more open and curious way, trying to allow the experiments themselves to basically offer a new way to think about how we can approach duration, time, matter, and how those sensitivities of exploring, let's say, waveforms can explore kind of issues of arresting things in space, organizations that are operating in ways that in some ways are allowing us to leverage, I think, the computational affordances that we have today in ways that we weren't able to do before. So the notion of simulation plays a big role, but also this aspect of wonder, how a particle itself can be levitated and controlled, and how that control can exhibit different ways of thinking about how things can challenge the logics of how we perceive and see. So for example, here, designing a prototype that controls these foam particles in space and allows us to be able to move them and rotate them within a field. So this isn't the field like, let's say, Stan Allen was promoting in the late 90s. This is something fundamentally and radically different. And the power of actually looking in a form of discovery is actually looking for opportunities to understand the differences. The previous experiment was done with foam balls, but these are liquid droplets. So the same waveforms are holding through surface tension, the ability for these droplets to be controlled in space. And what this starts to bring into question is that whole notion of wave and particle being something that could be hybridized and give a sense of what the world actually is in a way that potentially we wouldn't have access to. This has been coupled with a long-standing relationship of sort of questioning what people are calling artificial intelligence or machine learning, trying to develop systems that actually are goal-oriented and are basically working in a similar way, but making a meaningful distinction between a particle and an agent, and what that actually means, versioning and using digital playpens, gamification as strategies to be able to understand the relationship between one and another. These things have evolved into different experiments, different kinds of tasks that are basically operating on prototypes that we're building on in the studio, and also focusing on different forms of communication that are not necessarily top-down, but they're conversational. So here, using BCI wave functions to be able to create a much more haptic relationship here between DDIM and training systems. In this case, it's not a one-way conversation. It's not training the system. It's training the relationship between the system and the participant, and how those things go out in the world and in some sense refactor our relationship to how we can participate with, let's call it, the development of different forms of intelligence. The relationship to tools, I think, is also something that has evolved. You know, when in the late 60s, early 70s, the Whole Earth Catalog was basically an attempt to document all the tools. And it had language in the first catalog that basically spoke to this liberation. The catalog's introduction says, "We are as gods and might as well get used to it." Read the first catalog statement of purpose. "A realm of intimate personal power is developing, power of the individual to conduct its own education, find its own inspiration, shape its own environment, and shape adventure with whomever is interested." The language of this is more of an empowerment of having access to tools, but the tools have changed. And obviously the space of those tools is also changing. And I think the relationship that we have with things is much deeper and much more entangled and necessitates, I think, a radical different understanding. And this is where I think some of the quantum principles become interesting. The Eames, I think in movies like The Powers of Ten, I think understood a form of speculation, trying to communicate and make this accessible, taking the opportunity for zooming out from a picnic to the cosmos.
The picnic near the lakeside in Chicago is the start of a lazy afternoon, early 1 October. We begin with a scene 1 meter wide, which we view from just 1 meter away. Now, every 10 seconds, we will look from 10 times farther away, and our field of view will be 10 times wider. This square is 10 meters wide, and in 10 seconds, the next square will be 10 times as wide. Our picture will center on the picnickers, even after they've been lost to sight. 100 meters wide. The distance a man can run in 10 seconds. Cars crowd the highway. Power boats lie at their docks. The colorful bleachers are Soldiers Field. This square is 1 kilometer wide, 1,000 meters. The distance a racing car can travel in 10 seconds. We see the great city on the lake shore. 10 to the 4th meters, 10 kilometers. The distance a supersonic airplane can travel in 10 seconds. We see first the rounded end of Lake Michigan, then the whole Great Lake. 10 to the 5th meters, the distance an orbiting satellite covers in 10 seconds. Long parades of clouds, the day's weather in the Middle West. 10 to the 6th, a 1 with 6 zeros, 1 million meters. Soon the Earth will show as a solid sphere. We are able to see the whole Earth now, just over a minute along the journey. The Earth diminishes into the distance, but those background stars are so much farther away that they do not yet appear to move. A line extends at the true speed of light. In 1 second, it half crosses the tilted orbit of the moon. Now we mark a small part of the path in which the Earth moves about the sun. Now the orbital paths of the neighbor planets, Venus and Mars.
You get the idea in terms of it zooming out, and we'll give a little snapshot of the zooming in.
Now we reduce the distance to our final destination by 90% every 10 seconds, each step much smaller than the one before. At 10 to the minus 2, 1/100th of a meter, 1 centimeter, we approach the surface of the hand. In a few seconds, we'll be entering the skin, crossing layer after layer from the outermost dead cells into a tiny blood vessel within. Skin layers vanish in turn. An outer layer of cells, felty collagen. The capillary containing red blood cells and a roughly lymphocyte. We enter the white cell. Among its vital organelles, the porous wall of the cell nucleus appears. The nucleus within holds the heredity of the man in the coiled coils of DNA. As we close in, we come to the double helix itself, a molecule like a long twisted ladder whose rungs of paired bases spell out twice, in an alphabet of 4 letters, the words of the powerful genetic message. At the atomic scale, the interplay of form and motion becomes more visible. We focus on one commonplace group of 3 hydrogen atoms bonded by electrical forces to a carbon atom. 4 electrons make up the outer shell of the carbon itself. They appear in quantum motion as a swarm of shimmering points. At 10 to the minus 10 meters, 1 angstrom, we find ourselves right among those outer electrons. Now we come upon the 2 inner electrons held in a tighter swarm. As we draw toward the atom's attracting center, we enter upon a vast inner space. At last, the carbon nucleus, so massive and so small. This carbon nucleus is made up of 6 protons and 6 neutrons. We are in the domain of universal modules. There are protons and neutrons in every nucleus, electrons in every atom. Atoms bonded into every molecule out to the farthest galaxy. As a single proton fills our scene, we reach the edge of present understanding. Are these some quarks at intense interaction? Our journey has taken us through 40 powers of 10. If now the field...
I mean, if something is to be said, I mean, the Eames were working, with a boom behind of a truck and not short of really trying to use all assets to be able to communicate, I think, something that was very fundamental. Speaking towards, I think, not only the relationality of things, but also the elemental. Rovelli says, if we give a description of the world that ignores a point of view that is solely from the outside, of space, of time, of subject, we may be able to say many things, but we lose certain crucial aspects of the world, because the world that we have been given is the world seen from within it, not from without. The conversation, I think, with Rovelli for me was very important because it also spoke to the fact that many of these kind of conversations don't exist. In a time when we have a great degree of specialization, having the capacity to be able to have conversations that cut across, I think, all disciplinary distinctions are generally rare. They try to be institutionalized within university systems, but they don't really operate in this way. And I think, in some sense, a lot of the things that we spoke to was really about understanding the world, the word of architecture, as he is usually spoken to, he says, as the architect of quantum gravity, I'm sorry. And that is something that he found very important, as his relational aspects and granular concepts of space and time are very much predicated on the way of constructing these kind of relationships and world building. For the piece that we showed at the AA that I spoke to, we've been for the last 7 or 8 years working explicitly on trying to come to terms with certain desires for us to be able to work through art, architecture, technology, and science. And for the piece that we were asked as a response to the work of Yonah Friedman after his passing to basically be in a position to evolve or critique some of that work, we took the title of The Order of Time from Rovelli's book. We looked at Yonah Friedman's desire for a scientific architecture, and we were influenced by John Conway's work with Game of Life and sphere packing. In the Eames movie, 10 to the power of 10 is an important benchmark, and to the left you'll see John Conway's Game of Life also spoke to 10 to the power of 10 as the field space in which the game of life would be played. Conway, for those of you who don't know, was a mathematician, and the game of life was actually one of the simplest rule set game logic that he developed. He became well known for that. It became a tool for many people to be able to understand seeding logics and to explore a kind of model of space that everyone could influence but no one could control. This played an important role in the way that we thought about developing certain aspects or strategies that free men have towards a participatory architecture. Had the pleasure of seeing a bit of Conway's archive, and Stanford basically organizes this special collection as Conway's correspondence on life, which I thought was very interesting. And the correspondence and the text between all of this is a series of rule sets, but it was also about a description of the language that would be important to speak to what these generations actually meant. It was a move away from abstraction to make things accessible, at the same time to gamify an environment that would allow people to participate. He saw these different generative aspects in which some of these seeded logics would be enacted as a survey of life forms. And I think this generative logic, generative design logic, I think is something that has resonated with me for a long time. But I found in Friedman's own archives, also having the conversations with his daughter, some of these drawings which were field spaces for projects that actually weren't really enacted. They were speculation about really what are the waveforms and the thoughts that could actually start to speak about the different kind of organization of work. Things like spatial, Villa Spatiale, and all of these things had these kind of proto-genetic sequences, things that you could see in the development with the work he was doing at the Architecture Machine Group. But these were speaking about almost a very kind of top-down, even if it was a bottom-up organization, that was very much dictated by the grid in this case, or by the circle. And just to give a little bit of a context of how we've come to this conclusion of the work this last, let's say, 6 or 7 years, a lot of our practice in Minimaforms from the beginning was always kind of speaking to new forms of communication. We did a project called Memory Cloud, which was a participatory work, which we tried to fuse one of the oldest forms of communication, which were the smoke signals, and with SMS and mobile phones. At the time that we did this in London in 2008, this was held in Trafalgar Square. The London Telegraph said it would be potentially one of the most dramatic and obscene art events ever to happen in London, because we wanted to create an opportunity where public space was public, speaking to Trafalgar Square as a space that has always been a space for celebration as much as protest, and speaking to forms of communication that were both visual and also digital, and that hybridization creating a kind of third-order space in a second-order cybernetic way through the idea of animating the built environment through conversation. So prototypes of this event had happened in different places, but we've basically performed it in 2 places that resonate with us. One was in Trafalgar Square, which had its mix of novelty, of personal testimonies for lost ones in 2008. But this ephemeral event that took place over 3 nights took a year of planning with all kinds of safeguards for riots and everything else that comes along with this notion of free speech. We performed it 2 years later in the city of Detroit. We were working in the city of Detroit for 2 years on a light rail intervention on Woodward Avenue, and the DIA basically said that they could introduce us by holding an intervention. For 2 months leading up to it, haiku workshops were basically led with children. All the museums were basically in collaboration, bringing people to this event. And what functioned as basically the same kind of intervention in a radically different context opened up a different discourse, which was the city as a canvas, a place to voice testimonies and to have a conversation that brought people together. Memory Cloud Detroit, from those 3 days, stimulated enough conversation afterwards for the city and local authorities to come up with a light biennial called Electricity, which is still going on since 2012 till now. And what was an intervention that basically was an ephemeral, durational, let's call it participatory structure from our side, became something that is celebrated by the community, and people are using it not only to invite international artists, but basically to host a lot of Detroit artists to use the city as their own canvas. The testimonies themselves was a collective act of writing space. Each testimony was part of this evolving text, and it was an important project in my brother and mine career, because in some ways it spoke to the fact that every event, any intervention has the power to change the way that people see their context and give voice or agency to things. I'll show one more project leading up to the two that I'll speak to. The other project is Petting Zoo. One of the things that I think is important about having your own studio, your own platform, is to create the space to also try things. Research takes time, and with my brother's an artist. He studied at Central St. Martin's and at Rutgers, studied typography, studied painting, studied interactive art, and I was trained as an architect. What we were exploring with Memory Cloud as a contribution through testimony in Petting Zoo, we basically designed a strategy to rethink the relationship that we would have with intelligent systems. Sorry, let's see if this plays. So it looks like my friend's computer is having some issues. But anyway, you guys could use your imagination. What you see here are robots that were designed as emotive creatures that were installed at the FRAC and the Barbican and a host of other places over the last 10 years. Most of my colleagues in architecture, like most universities and so forth, spoke about robotics, but in an industrial way, basically utilizing industrial processes and all the constraints that they were designed for in ways that were somehow given a platform to look at as a building system or a fab lab and things like this. What I thought was very important was to speak to what it would mean to live with these kind of emotive systems, to generate an installation that used machine learning to develop strategies that would interact with people, a vision system that would allow them to communicate through sound, through kinetics, and through communication. The project itself, regardless of what it looked like, basically was installed in environments that basically tried to challenge, the habitual in some sense. And in the FRAC, it was in a gallery. At the Barbican, it was outside of the gallery. We installed it in the main public space. And the piece itself became basically very easily synthesized, and people enjoyed it and then also tried to understand how it was basically communicating with them. Each of the robots basically had a short-term memory. We used blob detection to be able to identify different participants in the scene. And a lot of the work that we've been developing was always about making people who participate as part of the performance. They were part of the system. The system itself is the communication between us and these things. So the conversation between human and machine, or machine and machine, is something that is very important to us. The Barbican, for those who don't know, is a quite large brutalist complex, but it was installed in the main thoroughfare. And the pieces themselves evolved over the time through the interactions. And we have shown the piece now, most recently last year in Brazil at the Museum of the Future. And the piece itself continues to evolve, and it gives us the opportunity to look at installations as a way to sort of test also our assumptions of context and how it responds. We've tried to develop these models in things like projects like Emotive City that were, in some sense, invitations from the Innovation Lab of the UK to speak about what the future of machines are. And we spoke about the future of machines as architecture and urbanism, as a form of infrastructure, a way to think about the possibilities for things themselves to have agency, to create space, to challenge the orthodoxies of the blueprint and the master plan, to be something that could evolve with us. And it's not about style or any sort of kind of way of thinking about sensibility. It's about something that can co-evolve. So a lot of the work over the last 2 decades has been really working within that domain. To finish off with the order of time and a project called Oven in the World, Friedman spoke to a lot of these participatory logics, but in some sense, wasn't enabled by technology to take it to a place where some of the implications of what he was speaking to would be able to play themselves out. So many of his self-build hypotheses and so forth, I think, have been a great inspiration to us, but we thought and saw very quickly the limitations of the circle and the square, the notion of the grid, and we questioned the idea if we use the sphere and the cube, an idea of voxelization, and speaking about resolution of space and different forms of organization, if we could take some of the promise of what Friedman was being asked in this interview for a project that he developed called the Choice Machine, which is better known as the Flat Writer. He was said, "Mr. Friedman, will you tell us about this machine for inventing apartments?" This was on a French broadcast. He says, "I call this a choice machine. In practice, we say that there are an incredible number of possibilities for apartments. You can make millions and millions, and if I make a whole repertoire, I will call it a menu of these machines. All possibilities are shown from which anyone can choose anything, whichever one they want. It would have been a huge book just full with little plans. Instead of that, I make something like a typewriter. That is, that instead of the book, I make the tool which prints the book." And I think the promise of a lot of the things, the early ideas of the rule sets that Flat Writer was basically working towards, played an important seed for our own kind of development, a response to his au revoir. Wolfram's kind of notions of cellular automata connected back the relationship between mathematics and computation, and the desire for Wolfram to think that everything, in some sense, could be described through mathematics. Our world, as I was mentioning, was trying to challenge the orthogonal nature of the grid that he was using. So the spherical packing gave us strategies of nesting and gave us the ability of looking at the cube and the sphere through recursive relationships, where the sphere internalizes can show a newfound affinity of cubes within spheres, within cubes, within spheres. And a lot of that work, we tested it out in the, let's call it John Conway's 10 to the 10, with a game of life simulation that was recursively part of the exhibition, which we took 3 instances of to basically build as these perceptual machines. And so here, in the same spirit of powers of 10, you start moving from one cell, which was that blinking white stroboscopic effect, into now the potential of thinking about this as an alternative to what we understand as a traditional master plan. The rules of the game are explicit, but it's durational and seeds can be added at any moment in time. The relationship of that is that no one can completely control the system, but everyone can influence it. And I think if we had to speak to a model of relationality for the urban, and particularly in the way that computation sort of plays a role in it, for us this is a meaningful kind of communication and conversation with the work that Friedman was trying to develop. And from the 2D sets to taxonomies of different kinds of organizations of structuring, and to unfolding 2.5D and 4D versions of the game of life as ways of seeing how these genetic systems evolve and create space, and how that game, through a gamified environment, would allow this basically different ways of understanding these mathematical rules, and how people's participation basically has an influence in it. It still works with a high level of abstraction, but almost like a game of Go, it has its own rules that become legible. The exhibition obviously had also forms of representation in terms of early study models, sketches, and all of the things that we've been working on. But in principle, the pieces, the vitrines themselves were perceptual devices in some sense, looking at a lot of the glass structures that we've been working on in terms of lattices and in terms of these cellular automata systems. The fluorescent lights basically using the wooden spheres to render them almost as digital objects, and the mirroring to create linear and non-linear organizations in terms of the reflections and the context mappings of how people walked around these pieces. Much more interesting than the photographs, I have to say. So if we install it somewhere here, I would encourage you to at least have a look. And the last project that I'm going to show is a project that is ongoing. It's been 7 years now, but we still are kicking on this. At Somerset House, we've been asked to be resident artists and to pilot their artist initiative there, which is the largest arts initiative in London. And so at that time, there was a conversation about how we could communicate our intervention and communicate Somerset House to the general public and the general public back to Somerset House. This is Somerset House, and this is the main courtyard where they have a fountain. We try to create basically this reflection space and this glass lattice of 1,500 glass orbs. Basically constructing 3 hypothetical offset spheres that have constellations of glass orbiting around each of the nodes. The piece itself is a kind of anti-object, anti-image. Everything that you see, like in Van Forester's kind of description, is your own. Basically, the way that you see through all of these things within each node is basically the relationality of all neighboring nodes. So the piece itself becomes more than a looking glass. It becomes a kind of model of this kind of cosmology. Here you can see the general organizations of the piece, the way that we're building it, which is quite challenging when you're working with glass and acrylic rods, because the piece itself works purely when it's complete. But the whole logic of its erection process is quite a challenge. So these star panels and the actual crates for their shipping are part of the erection sequence that we are using to basically have 12 mega panels. And you can see some of the glass orbs that are basically being looked at, and what 1,500 glass spheres actually looks like. The piece itself, each node is unique, and each one of them is basically robotically milled and all of this other stuff that goes with digital design. But this is an opportunity to also understand the difference in weight and displacement of glass, because it's not uniform in that way. So we're developing these prototypes, which also become tools to communicate. And that was the project that led into the conversation with Friedman. And I just close with a final slide, which is the working document for the quantum book that will have a conversation with Ravelli, a conversation with Hans Ulrich and David Deutsch, Hans Ulrich with myself, and Ariane Koek, who started the arts program at CERN. So with that, I'll leave you with this quote with Carlo Ravelli. We're nothing but images of images. Reality, including ourselves, is nothing but a thin, fragile veil, beyond which there is nothing. Anyway, thank you. If there's any questions, happy to answer them. "55 minutes, Laura. You don't have to worry." Is there any questions? Please.
The 3D models developed, did you find any convergent structures that, or maybe repeating motifs in the architecture or organization of the structure?
Yeah, I think what you quickly start to realize is that purely mathematical models don't necessarily have material translation. So the notion of iteration always has to come with a very kind of, let's say, sharp-eyed inspection of actually what's being generated. So we've always worked in a kind of generative approach, trying to really understand the relational aspects. We use spheres and cubes quite a lot, not because I mean, I like spheres, it's clear, but the reality of those things is computationally we can deal with a very high resolution space, so we can always negotiate some of the material manifestations with a computational logics, but it's a very nonlinear approach to that. But simulation is something different than just animation, and I think there's very important distinctions that need to be said in terms of how one writes the rules and how one uses prototyping as a way to gain an insight in the behavior of things. So I did a PhD on behavior, and if anybody's interested in that stuff, you can find it at the UCL website. But I think it's important to see that some of those early conversations that were more thought experiments, powered with some of the computational apparatuses we have now, gives us, I think, the ability to be able to explore that domain and with much more continuity. So not like experimentation for the sake of it, or not just to try to build form. Even the name of Minimaforms basically is coming from the idea that form is a moment in time. So minima is that moment when form comes into being. And when me and my brother tried to come up with a name for, let's say, our practice, it was more about a statement to try to understand that the world is evolving and changing, and latency and uncertainty is a very big part of, trying to challenge not only the orthodoxies, but the assumptions that we make for design. So not just how we structure stuff, but how people can be enabled and curious and, make it their own. So I tried to speak about some of these installations because they, I do think, go beyond drawing in terms of the kind of input that we receive and the conversations that we have with people that somehow really seed, I think, the next generation of the way that we're thinking about things. And, some of the work is quite old. 15, 20 years for today seems like an eternity, but I live by every project that we've done, because in some ways it's always been rooted in the kind of question that we're asking. So I think Cedric Price is like one of these godfathers at the AA. His ghost remains quite strong. And he said technology is the answer, but what was the question? And I think it's an important thing to think about the way that we really somehow demystify tools and also demystify the agendas that we have to make that more accessible to people and really sort of work on those things. And I feel with the quantum sciences and so forth, we're given an opportunity to just see that we're part of something that's much, much bigger. So what we want by itself is not necessarily what the world needs. So I think it's just a reminder with some humility that design matters, but responsibility also is part of that design agenda. Thanks for the question. Please.
Thanks. I'm thinking about that quotation you just cited about technology is the answer, but what is the question? And I want to go back to when you were talking about the methodology in the research lab.
Yes.
Of letting the experiment drive the process of discovery towards a question. So I'm curious if you can talk about an example in the lab, perhaps now, of how that process works and what kinds of questions you've been generating.
Yeah, I think from my perspective as a director is really to try to create the least amount of obstacles as possible. Create a framework that has no hierarchy, so everybody feels that they're an active participant. And we work together collectively, which is something that's not really taught in education. We're trained as architects as solitary figures, but the practice of architecture is very collective and necessitates communication with many different people with radically different needs, desires, and thoughts behind what it is that they're contributing to a project. So for me, I think it's very important that it's framed in a way that has some guiding rules. We have very large, let's call it umbrella thematics that will last 3 or 4 years. And those are worked on by teams of 3 or 4 students and staff. And so we may have, over the 22 years I've had over 1,000 students. So research is not just one individual's contribution, it's a collective work that's emerging, that's very much about the individual's participation, but the actual outcome is for questions that go beyond us. So I try to leverage the background of my students that are very international. They're all architects. But if you look at some of the stuff that we do, or maybe next time I come here, I'll show you guys explicitly the DRL stuff. It varies from the scale of urbanism to housing to gamification, metaverse. The things that I'm working on right now is, something that I'm calling elemental, which is really trying to look at things like desertification and sand welding as strategies to deal with large-scale ecological crisis. So challenging, let's say, the notion of sustainability and this ability to think that we can't actively engage in these problems, and leveraging the optimism that also students bring, not only to keep me young and always on the go, but also to really participate in problems that our students are going to go back to their countries, and that they feel that they have agency in a community to respond to large problems. So it's not just about getting a job, it's about having a statement of purpose. And I think, there's a lot of factors. We need a job, we need a paycheck, we need all of that stuff. But I think the bigger project is closer to like Buckminster Fuller's idea of the 50-year experiment. It's every day contributing to a certain way of rethinking our own orthodoxies and seeing how that can be much more inclusive. So I show the installations because I still feel that those are the most direct ways that we can prototype and work with people. And that has been very influential to not only my practice, but I think the way that I approach education. So I'm very happy to speak about these things, and I'm very happy that you guys invited me, and Andrew invited me to give a talk here, because I feel like education is a bit in a moment of crisis. I don't think people are speaking to the role that design plays and the importance of, basically thinking about design and experimentation as offering more. People deserve better, and we can find, I think, ways to work with constraints in a meaningful way. I leverage computation because I think it's some of the meaningful differences today, especially with a lot of the accelerated, almost instantaneous architecture that people somehow feel like architecture could just happen. It's a slow form of resistance, to be honest, which I think is not a bad thing. And it is a challenge to technology, because people think that once technology is out in the world, they can put it back in the box if they don't like it, but it really doesn't work like that. So I just feel like making things conversational, but making it very project-based, I think challenges people to, take ownership and responsibility, and also feel that they have a support structure to basically try things. Failure is okay. Not in the final form, in the final iteration, but it's like Samuel Beckett said, fail better, fail again. I bastardized the quote, but anyway, you guys get the sense. Thank you for the question. Anything else?
The Richard Serra piece of Catching Lead, I hadn't seen this before, but I feel like it's a very beautiful metaphor for your work in a certain way, that there's this sort of like ephemeral but actually incredibly tactile thing that's elusive and that you're striving for. And in the process of research, you grasp it for a moment maybe, and then it moves on, and there's sort of a different state. There's this sort of like, it's the Heraclitus version of reality in a way, which I think is, it's very poetic. I was a little bit curious actually about the contrast between the Game of Life version of Powers of 10, your Game of Life version of Powers of 10, and the Eames version of Powers of 10. Because, in the Eames version of Powers of 10, there are very specific moments in which you begin to feel scale dependence, and you begin to feel the distinct logics that play out at those different scales. And there's a sense of kind of like, there's a sense in which there's a particular gestalt that emerges at each of those scales, which is distinct and operates in a kind of different way. It's a kind of like meta-phenomenal kind of, I don't know if it's emergence exactly, but it's a meta-phenomenal way of seeing all the scales below, but it's not the scales below. It's actually, it is something different. And so I was curious, in the Game of Life Powers of 10, there's a sense in which there are those kinds of maybe epiphenomena emerging, but at the same time you see the particle is always there, and the particle is like the atom of the entire project. And I'm curious, like as a research project, it makes sense to sort of examine things in that sort, with that sort of level of rigor and sort of, consistency. But I'm curious your thoughts about those questions of sort of scale dependence and sort of, the distinct kind of logics that emerge at those different scales and the interplay between them.
Thank you for the question, Andrew. For sure there's a difference between the Eames movie, which is describing the world as is, and the notational, basically, description of basically trying to build on Friedman's legacy as almost like a proto-proxy kind of system of rules. It's not meant to be something that is without translation. And in some sense, the spirit of what Friedman spoke about, which I think was very beautiful but also slightly naive, is the fact that everybody could actually just self-build their city. And I think at the different scales and the different resolutions, different problems emerge that necessitate, I think, an active interrogation. When I did Adaptive Ecologies, I think it spoke to that a bit more directly and was working at 3 scales at the same time. It took an approach to a form of, let's call it computational urbanism, that started from basically a studio apartment or a room, and it worked outwards to the block, to, let's say, what we would call the collective or the city plan. And I think the reason for that was the idea that if you don't believe in a blueprint or a master plan, what embedded within a computational logic will allow you to build those systems of correlation at the different scales and recursively potentially ask very different questions, let's say from an interior of an apartment, more based on stuff like safeties, habitat, whole host of different projects, metabolism, all that stuff. And then things that were much more emergent at the urban block, to relationships to other models of urbanism and Barcelona blocks and other kind of proto-patterns that you could see descriptions in the work of Christopher Alexander and others, but they were never tied to a form of like active interrogation within, playpens that you could actually really start to interrogate, localize, and see what that resolution space would actually really mean. So the gamified spaces, I think, these days allow us to deal with, higher population of basically agents, if those agents are unitary as homes, if they're ideas of challenging, let's say, ideas of master plans. These aren't for total cities, these are indexes for something. And that's why I interpret them as proxies. And in that particular project, really just trying to speak to Conway, the discussions that Friedman had, which, to be honest with you, Friedman and towards the scientific architecture is very different than the Friedman that everybody knows and loves. It was part of that world like Negroponte's, who basically wanted in some ways to refactor the role of the architect or remove the architect as a figure that is working with design and let the system be the system. I don't really have that belief of the system running wild or just an algorithmic accumulation. That's why I feel somewhere between the generative work and some of the thought experiments of early AI, I think will serve us well to revisit, because I think right now people are just doing the lazy and quite easy diffusion strategies without really interrogating it. I teach diffusion models to children that are 11 and 12 years old that come to the AA. I do workshops with them. So they're not architects. It's a great way and a great tool to bring people into the conversation of what their city could be like and to kind of stimulate curiosity. But I think architecture makes a lot of serious demands. So yeah, I think our film is very, very limited in that way. It was just in some sense trying to negotiate some of Friedman's promises with a mathematical model that allows people to treat it like a game that people could participate in. So kids could play and be a city builder just as much as a developer. So the idea of who participates isn't biased, because once again, their move is just like anyone else's move. That lends itself to a lot of generic space and all of that stuff if you take it literally, but if you take it as an index of strategy, I think it does offer something to interrogate and discuss over.
And I would say, just incidentally, Elizabeth and I, for example, have conversations about this sort of like state or qualificational boundaries of design research, and I really like this sort of idea that design research is this, one quality of design research is moving beyond representation into prototyping, and that at some level design is entangled with representation, but design research is very much invested in prototyping, and I think that distinction it's a super useful one, actually.
I think it's an important one because even in the most generic buildings, we go from design to realization. Almost every industry has some fail-safes. We are in a situation where I think if we're trying to upgrade the conversation, we have to find different models to be able to work through some of the challenges that we're working on, if that's fabrication, if that's organization, if that's a desire to make things more participatory, we have to, I think, construct. And that's where I feel universities, education needs to be kind of looked at slightly more holistically about what is the overall agenda. So, I work at the AA, and I can say that the AA has no resources, and I'm sure my director won't be very happy for me to say that. But what it does have is a lot of people that believe architecture matters, and they're coming to a place because they believe that they can explore stuff. And I think that what motivates people, I think, is very important. All the access in the world doesn't necessitate a form of real inquiry. That being said, there are obviously glass ceilings, so a lot of the work that I do with my students, I think, some of them are successful entrepreneurial projects, but you also see how that changes very quickly into something that's all about market and money and investment, and it changes the spirit of really what set up the problem. So I don't think that there is a right way. I definitely think that there are wrong ways. And so I think collectively, between all of the experiences, we just try, and like we're doing now, I think try to see what resources we have to work collectively on things and to, really challenge things. I don't think that people should feel very comfortable about how architecture sits in the world. So I really do feel like it's important for me to speak to some of those things, like a responsibility. And otherwise I'd be sitting in my studio just kind of going to town kind of thing. And so I feel like conversation in a Pasquian sense is very important because, in his way, he was really trying to challenge architecture. He said that architecture has no theory to deal with the complexity of the day, and that he said in the 70s. So if that's the case, he thought cybernetics could contribute something meaningful to that. I agree with him. Second order cybernetics, first order, not so much. American cybernetics, not so much. But you start to see, like, when you're thinking through some of these problems collectively, how complex things can evolve quickly, and that becomes a really interesting search space for design research. And I think that that's what makes it fruitful, and students learning from each other and educating themselves too. As much as I can contribute to a conversation, I feel in a meaningful way they can too. They just need to be afforded a framework, I think, that not only enables them, but encourages them. So I don't think it's just about talking. That's why I think prototyping is very important. And that just means like having accountability to push it within the constraints you have. And then I think good things happen. And anyway.
Yeah, I really appreciate the the way that you started the conversation, sort of paradigm shift for architecture, and the sort of, I don't know, we're on a precipice sort of situation. I'm very curious. I can imagine very clearly this idea of how relational systems and models for growth or decay operate at the material or submaterial scale,
Yes.
and at the urban scale certainly. But architecture is this kind of point of friction which really resists that. And we obviously understand metabolism and the sort of modular growth paradigm, but I'm wondering if you have any thoughts on a more contemporary way of thinking about how the DNA of architecture at that kind of mesoscale might be challenged right now, or that's just a fundamentally social paradigm that has to give way to collaboration in the market, or what that might mean.
I mean, your question is a challenging one, but I don't think that there is a answer for it. I just think that there's a certain orthodoxy and habitual nature of how things are, that they're just blindly accepted, which I think, to be honest, I know isn't the answer. But I do think that architecture can't just see itself holistically. I think, for me, I explore a lot more architecture as a form of infrastructure, and that may mean building, but it doesn't necessitate that it is building only, because I think these distinctions between planning and building and developments and stakeholders and everything, the conversation, I've been in practice, I've worked, it's not as interesting as people want to make it out to be. And it's not that entrepreneurial, it's very risk averse, and those constraints may still remain, but I do feel like there are other problems that are not going to be solved at that level. And I think as long as architects can participate and not let developers build with no architects involved, which is basically what most of it is happening anyway, then I think we can start to address some of these issues. That's why in my own work I've been looking at the climate crisis a little bit more explicitly. And primarily because there's materials like sand that we could fuse. There are ways of seeding, controlling water droplets, water harvesting systems, things that can be super low tech but actually have a meaningful contribution. There's a lot of people on the move, but we always talk about buildings in a fixed and finite way. So I just feel like the more we can sort of break this kind of idea of what a building is as architecture, and with the capital A, I think the better we'll be able to serve these problems. Because I don't think that there's a solution space that really addresses it in a generic way, or at least I haven't found it, and maybe I'm very averse to that anyway. But thank you for the question.
Yeah, I'm actually having trouble formulating this question, but I'll just give it a shot. Yeah, the work is, I'm totally blown away with all this and the many points of inspiration. You talk about cybernetics, which is interesting, but a lot of this stuff seems to me to make me think of relational biology.
Yes.
And I'm just curious, like, if you've explored that at all, or if you've thought about that at all, or yeah, I guess I'm not sure what more to say than that, other than it's a field that kind of arose around the same time as cybernetics,
Yes.
but kind of disappeared, and not many people talk about it or know about it. But it feels like a lot of the things you're doing a lot of the way you talk about things is in line with a relational biology perspective on the world, and so that's.
No, thanks for the question. I mean, I think I understand where you're going with it. I mean, Umberto Maturana was, really working in the world of biology and, speaking to systems and trying to think about autopoiesis and cognition. And I think what I find very interesting of the 50s, 60s, and 70s was they didn't really have access to technology, but they came together in these Macy conferences, radically different professions, basically none of them in a home institution to speak about the problems of the day. And I thought that those was a very kind of empowering thing to see some of those conversations then and where some of that stuff has gone now. I mean, there was a moment where I was looking at like Sean Carroll and evolutionary developmental biology and things like that. And that's also something very recent, where we don't separate genetics from biology, and it's a fusion of different specializations of science. And I think that that's an amazing space. I think that that's, the medicine and biology, and that's the space where AI is really going to be tested. And I think we'll have, some important potential to kind of be, in the service of good instead of in the service of market. So I think all of these, if you have an interest in those things and revisiting that and seeing how architecture cannot use it as a metaphor or just inspiration, but really as a way to think through some of the problems that you guys are working on, I think it's always positive. I think it's, what Ravelli or David Deutsch, who are also not on the same page in terms of the way that they see quantum mechanics, but they all speak about this changing of perspective and a forceful change. And I think that that's what I do with the lab too. Every 3 or 4 years, I'll radically change what we're working on. If it's the scale of the city, we'll go down to the scale of the material, just to forcefully not break continuity, but just change the way that we approach those methodologies with a different, let's call it, target of an investigation. So I think these things are not profound in themselves, but I think once you're working within that and you have a commitment to it, I think you will see the deep connection into things, and that'll just give you seeds of not just inspiration, but I think things that you can action and conversations that you could have with people. I mean, this is the first time Ravelli spoke to an architect, and this was after he spoke with Cornelia Parker. This happened, almost a year and a half ago. So those conversations, I think, are things that sometimes just happen, and I like things happening. So anyway, thanks for the question.
So I think things have definitely happened tonight. And Theo, we thank you very much for this beautiful lecture that transects disciplines, scales, materials, philosophies. It shows us a little bit of a possibility of what design research can be.
No, I appreciate it. Thank you all for the attention and the platform.